The red color one.
It's not recording.
Yeah, it's recording.
It's
Recording, there's a red color dot here.
It's now recording now. It's recording now.
Let me repeat again. I will give the revision on the work and energy. And basically what you learn in Form 5, the work is just force times displacement, which is, let's say example, a simple example. I applied a force which is 30 newtons to this block, whereby the block is moving for 3 meters. Let's say this is a simple example. Then I can say that the total work done is just force times displacement, which is 13.0 times 3.00, which I think is about 90 joule. That is an example, which is what you have done in STPM. And we move further. In STPM or in A level or foundation in Utah, also the same thing, where we say that work is kind of the vector dot product vector, which means it's a dot product of 2 vectors. So again, from here we can say work is still scalar quantity, where it is actually force dot S. Okay, so from what you have done in the vector vector S is still give you a scalar quantity. And for this case, in the mathematical form, we can say it's a magnitude of force times magnitude of S times cos theta, where the theta here is actually angle between F and S. So with that, I give you one example. Let's say this is a block. Then I say there's a force applied here, and as a result it moved 3 meters. And this force, the angle is 30 degrees relative to the ground. And I say the total work done is 10 joule. So what is the force at here? What is the magnitude of the force? In order to get the one, I can try to say work equal to 10 joule, which is also F S cos 30, then which is also F3 cos 30, and this is 10 joule. Then with that, F is actually 10 divided by 3 cos 30. So this is an example to get a force, but the one is just a beginning. Let me move to the next. So when we talk about what we done last time, there is a shortcut. So work is actually the force that is parallel to the displacement and sigma there. Okay, this is a shortcut, whereby you can try to take a look. If let's say I give you this one, this is the mass. Okay, whereas the mass, let's say there is a frictional force, there is a normal force, there is another mg or weight, and you apply a force at here. So somebody press it at 30 degrees, something like this. Sorry, let me define this as F2, this as F1. So the question is, what is the work done by, or what is the net work done by all these forces? In order to get it, you just say work equal to all those forces that is parallel to the displacement. Let's say the displacement is 3 meters to the right. Then I can say that is F1 D represent the displacement, plus F2 cos 30 D. But here I put it a negative. The reason is the F2x here has a different direction or anti-direction from the displacement. The displacement to the right, whereas F2x is to the left. So you must put a negative. And for this case, there's another one which is minus FFR D. So there are 3 net forces that applied on this one to give the work. On the other hand, for the Fn and mg, we do not consider because these 2 forces are perpendicular to the final movement, final displacement. For those components that is perpendicular to the final movement or displacement, we do not consider. Okay, and this is the way to do it, so you can find out what is the answer. In general, in order to find out the work, then we may say that it's just force times displacement, whereas the force is perpendicular, is parallel to the displacement. Then we can get it. On the other hand, there's another method, similar question for this one. We try to find out what is the F net or sigma F. First, to find out this one, then second, we still use the same thing, which is work total, or net work is just F net dot displacement, which is still the same thing, F net dot D, the magnitude cos theta, where the theta is the angle between F net and D. And so, let's say I give a one complicated example. Something like this. So, there is a spring here. Then, initially it is unstretched. It goes through a massless pulley like that, and this one there's a mass, of course. So due to the gravitational force, the object is sliding down, and let's say I say that the object is sliding down 3 meters. It becomes like this, and here it stops here. So I ask you to analyze this question. How do you do that? This is something that's a complicated question, which is normally asked in the exam, in the tutorial, in the test. So, before I move that, I would like to give you two relevant equations for this. First is work total equal to delta KE. Whereas second one is, which you have learned it before, delta PE plus delta KE equal to work C plus work NC. Sometimes we name this one as a work external because it's due to the external forces. So for example, before this, let me focus on number 2 first. Before this, what you have done last time, like for example roller coaster, for the ideal case, okay, we say delta E equal to 0 because there is no external force or external work done on the system. So delta PE plus delta KE equal to 0. This one is for ideal case where there is no external force, no other like frictional force or any other external pulling or pushing force. So at the highest position, it is PE max, but KE is 0. When I move down here, KE max equal to PE max, but actually PE is 0 at this position. Okay, on and off. That is something you learned last time. So based on this equation, you can solve a lot of problems. So including this one. And in our syllabus, instead of for the delta PE G gravity, we also study delta PE S for the spring. And you should know that for the spring, delta PE means mgHF minus mgHI. Delta KE means half mv squared minus u squared. Delta PE, there's another one which is spring, means half kx final squared minus half ksi squared. So this is G. And for this case, we can start from here. So let me analyze this question. Let's say, in order to get it, if I say this one, all ideal case, no additional force, no frictional force, then I can use delta PE plus delta KE equal to 0. Then I say delta PES because there's a spring plus delta PEG because due to the gravity plus delta KE equal to 0 for the whole system. Okay? So with that, delta PES, which is half kx final square minus half kx initial square plus mg h final minus hi plus ke f minus kei equal to 0. And for this case, the final one, it is stress. If here is sliding down 3 meter, which means it is stress 3 meter also. As a result, half k3 square. Initially, there is no, it is unstressed, so it's 0. Plus, and here, this is the delta H. And you should know that delta H is d sine theta. So I can put it as mg 3 sine 60, let's say the theta is 60. So mg d sine theta, and because it is moving down or sliding down, so that this one for the delta p we must put a negative. Okay, because the final position is lower than the initial position. So plus, for this case, the final ke, no movement. Initially, no movement. So as a result, 0 minus 0 equal to 0. So, which means that from here, you can solve each other. Let's say the question is to ask you, what is the value of k? Then from here, you can continue to solve it. This is a good example to understand what is the conservation of energy when you want to solve this kind of question. And if I move it tougher, I make it tougher, there is another frictional force here, FFR. And whereas I say mu k equal to 0.5, let's say. Then this one, which will cover in foundation, will use another formula. There are two formulas to solve this question. First is to use delta PES plus delta KE plus delta PEG equal to work C plus work NC. And right now, work C plus work NC, because there is external force. The external force in this case is actually frictional force. And this force, so because it's has an opposite direction or anti-direction from the displacement, so I can put it as negative FFRD, where D is 3 meter. So with that is negative mu K FND, so which is also negative mu K mg cos theta D. That is the method in order to get it. And whereas for this term, it's still similar to the just now one, which is half kx final square minus 0 plus, actually I should put a negative since it's going down, minus mg d sine theta. So for this case, you can try to use this one. Okay, I repeat the question. Initially it is unstressed like this. Due to the gravity, it slides down. Okay, it is sliding down until 3 meter is stopped. Let's say there is such a case. So you can use this method to do it. Okay, so the second method, in order to do the similar question, which is we name it delta KE equal to work total. This one, the total including internal and external. So the internal means the gravity and spring. External means a frictional force and some other forces. So let me give an example. Delta KE for this case, you should know that it's 0. So which means work total also equal to 0. And for this case, there are 3 forces involved. First is the spring force. Second is the gravitational force, and the third is frictional force. So work for the friction is just negative FFRD. Why? D is moving down, F is pointing up, so it's negative. So you can get it's negative mu K mg cos theta D. Second one, the work done by the gravity. So work gravity is mg h. For this case, the object is sliding down and mg is also going down, so it's a positive, and which is mg d sine theta. Okay, and for the third one, which is the work done by the spring force, the spring itself is stretched, whereas there's always a restoring force to pull it back. So normally we say that the force is always anti-direction, has an anti-direction with the displacement. So which means that the work done by the spring most of the time is negative half ks squared in general. Which means that initially it is unstretched, then it is stretched, or else initially it is unstretched and it is compressed. Either one. Most of the time it's negative half ks squared. So for that, then we say work total is work friction plus work gravity plus work spring, which is work friction is negative mu k mg cos theta d. Work G is plus mg d sine theta, and the spring is minus half ks squared. Work total here is 0. Okay, because delta E is 0. So in this case, if you move here and there, half kx squared minus mg d sine theta equal to minus mu k mg cos theta d. Exactly same. So we have two methods to do it. The first is to use delta k equal to work total. The second one is to use the one before this, what you have done, delta PE plus delta KE equal to work external. Okay, from here, something like this, you can solve it. So, personally for me, I prefer to use this one because easier. We find out how many forces. We just find out what is the maybe positive or negative, the force or the work, and then the delta KE, then finish all. This one we name it kinetic work theorem, and I consider it is the easiest way to do it. Okay? So I think that's all. Thank you.